Hey guys, Mr. Wilson here. Today we're looking at solving quadratics by graphing notes. At the end of this video, you should know where to find the solutions to a quadratic from a graph, and you should be able to solve a quadratic by graphing. Okay, a quadratic has the general form of y equals ax squared plus bx plus c. To graph, we found the axis of symmetry of a parabola and then the vertex. Okay, from this lesson on though, we will be using the following form of a quadratic. 0 equals ax squared plus bx plus c. When you see a quadratic equal to 0, that means we are solving the quadratic. Okay. On a graph, y equals 0 anywhere on the x-axis. Therefore, when we are solving a quadratic, we are looking for the x-intercepts. Okay, there are 4 terms that are synonymous or synonyms for solving quadratics, and that is finding the roots, zeros, solutions, or intercepts. All right, and we'll run into those as we go through solving. So here it says solve the quadratic by graphing. 0 equals x squared minus 6x plus 8. The nice thing about this is it's basically doing what we just did for the last 2 sessions, our lessons. The difference, the thing that we want to make sure that we do as we approach it is like we substitute y equals x squared minus 6x plus 8. Okay, and so by substituting y equals 0, we find out that when our y is 0, that's where our solutions are, right? Okay, which kind of reestablishes that our x-axis, our x-intercepts are our solutions. Okay, so we do that, then we go through what we did last lesson. So we find our axis of symmetry, opposite b over 2a, so our b is negative 6, so 6 over 2, which is 3. So we find that our axis of symmetry is x equals 3. From there, we find our vertex. Our vertex can be found by plugging that value into our function. So y equals 3 squared minus 6 times 3 plus 8. That's 9 minus 18 plus 8. That's negative 1. Okay, so last step here, we make our table. And in our table, x, y, our center is 3, negative 1. Nothing tells us to have to count by something different, so we just put the numbers around here, and then we plug in our values to solve. Okay, so I'm plugging in 5. Different color. So now plug in 5 into our function. 5 squared minus 6 times 5 plus 8. I should have probably done 1. Anyway, 25 minus 30 plus 8, and that gives us 3. Do the same thing with 4. I'll do that up here. Okay, so 4 squared minus 6 times 4 plus 8, and that's 16 minus 24 plus 8, and that is 0. All right, so I'll get all that graphed. So I have 3, negative 1. X equals 3 here. 3, negative 1 is our first point. 4, 0. 5, 3. I'll use my symmetry to know that if there's 1 point here, there must be a point here. There's 1.2 to the right, there must be a 0.2 to the left. And so that is also shown in our table. Symmetry there, symmetry on our graph. Now let's fill this in and see that we understand what's happening. It says after graphing, how many times does the parabola cross the x-axis? And so we see as we look at this parabola, it crosses the x-axis once, twice. That means that this equation has 2 solutions. The solutions are where it crosses the x-axis. And that is at this point, our x is 1, 2. And at this point, 3, 4. Okay, 2 and 4. If you look at the table you created to find this, or to graph this quadratic, look at the y values corresponding to these solutions. What do you notice? When x is 2, y is 0. When x is 4, y is 0. They both equal 0. Okay, which makes sense because we substituted y for 0 at the beginning of this problem. All right, so solving is just graphing and identifying where it crosses the x-axis. So let's look at these problems. Number 1, we're going to solve by graphing. So x equals opposite b, -4, over 2a. A in this case is -1. So we find our axis of symmetry to be at 2. So I've got that. Axis of symmetry is at 2. So help us out in not having to find all 5 points when we evaluate our function. Okay, so now we found our first step, axis of symmetry. Second step, we need to find our vertex. We do that by plugging that into our function. So we go y equals negative outside 2 squared plus 4 times 2 minus 4. So that's -4 plus 8 minus 4, and that gives us 0. Yes, 0. All right, so our vertex is at 2, 0. All right, so now we make our table of values. X and Y with 2, 0 being in the center. Plug in our other values around it. Okay, 4. There's nothing stopping us from using these values, so I'm just going to use those. Plug them in. 0 should be pretty easy. 0 plus 0 minus 4, -4. 1 should be terribly difficult as we plug that in. It should be -1 squared plus 4 times 1 minus 4. So -1 plus 4 minus 4. So we get -1 there. All right, because of symmetry, we should know that these two are going to be the same, and these two are going to be the same. And remember, it doesn't just always happen that way. We chose the center, and then we made sure to choose evenly spaced numbers. 2 is 1 less than 1, or 1 is 1 less than 2. 3 is 1 more than 2. Okay, so that's why it works out that way. It's not that any numbers you put on the outside are going to be symmetrical. Okay, but now we have all of our points. 1, -1, 0, -4, 3, -1, 4, -4. Okay, and so we double check to make sure that it makes sense. Our A value is negative, and so it should open down, which it does. It has a maximum value. We're good. Okay, so as we draw our parabola, completed after we made our table and all that stuff. How many solutions are there? Remember, solutions are where our line crosses or touches the x-axis, and in this case, it's only 1. Only touches the x-axis once. What is that point? Well, it's where y equals 2. Or sorry, it's where y equals 0. And in this case, that's where x equals 2. So our solution, x equals 2. And we could kind of figured that out, that once our vertex was on the axis of symmetry, that was probably the only time it was going to touch it because of the symmetry of a parabola. Let's look at number 2. We have x squared plus 2x plus 3. Going through the same process. Finding our axis of symmetry. Opposite b, -2 over 2a. A is 1 in this case. So we find our axis of symmetry is that x equals -1. -1, 2, 2, 2, 2, 2. Okay. So there. Down. Okay. From there, 2. We need to find our vertex. We do that by plugging our value into the function. -1 squared is 1. 2 times -1 is -2 plus 3. And so that's -1 plus 3 which is 2. So our vertex is at -1, 2. And I see something here right now that hopefully we'll point out and understand as we go. So from there, make our table of values. Give myself some space, I'll do it down here. Making my table of values, x, y, and in the center of that table, my vertex, -1, 2. So nothing's stopping me from choosing the numbers around here. Someone say -2, -3, 0, 1. Okay, I'm going to plug 0, 1 because it seems like it should be faster. So 0 plus 0 plus 3, 3. All right, that was fast. And then I'll do the same thing for 1. 1 squared plus 2 times 1 plus 3. And that gives me 3 plus 3, 6. All right, so because of symmetry, I know this will be 3, I know this will be 6. Okay, so -1, 2, 0, 3, 1, 6. Copy it over, copy it over. Boom, 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 done. All right, so we graphed it. How many times does this cross the x-axis? None. So how many solutions are there? 0. No solutions. Okay, and no real solutions. We'll talk about that in a little bit. Okay. So, come on, buddy. So we see our 3 possibilities really here in the screen. We could have 2 solutions. We could have 1 solution. We could have 0 solutions. Let's talk about why we need to learn some more ways to solve by graphing, or solve by graphing. Why we need to learn some more ways to solve quadratics. Here's the disadvantage of solving by graphing. We have -2 plus 8x minus 5 equals 0. Let's go through our steps. First, we want to find our axis of symmetry. X equals opposite b, -8, over 2a. A in this case is -2, so 2 times -2 is -4. We find out that our axis of symmetry is at x equals 2. Okay, so that's this vertical line here. Cuts in half. So far, so good. Okay. From there, we need to find our vertex. We can do that just by plugging that into our function. So -2 times 2 squared plus 8 times 2 minus 5, 4 -8 plus 16 minus 5, negative, positive 3. Sorry. So we find our vertex is at 2, 3. I'm going to make my table. I'm going to put 2, 3 in the center. Choose some numbers around it. So 1, 0, 3, 4. Okay, plug those values in. So 0, 0, -5. All right, that should be easy. I'll do that with numbers. -2 times 1 plus 8 times 1 minus 5. And that gives me -2 plus 8 minus 5. And that is 6 minus 5 is 1. Okay. So then I have that as 1 and that as -5. Plug in those values. So 2, 3, 1, 2, 3. My vertex, 1, 1, 0, 1, 2, 3, 4, 5. Over that way, and 2 over, 2 over. Okay. So now we graph our line. Graphing our line. And I said graphing our line, but I meant parabola because it's not a line. Okay. All right. How many solutions are there? Remember, our solutions happen where our line crosses the x-axis. Where does our line cross the x-axis? Well, in 2 places. Here and here. How many solutions are there? 2. There are 2 solutions. What are the solutions? I don't know. I don't know what the solutions are. It's hard for me to tell based off of the graph. Okay, So this example shows two major disadvantages to solving by graphing. It's time consuming. It took a long time to get to that point, right? And then you're not able to find the exact answer in some problems because the parabola doesn't cross the x-axis at, we'll just say, nice points. Okay, it would have been really nice to cross at nice points, but it didn't. So we will need to learn some different ways to solve quadratics, and we'll be doing that in the upcoming lessons. All right, so that's solving quadratics by graphing. See ya.